For example, a vent pipe that was 634 rand, currently it is 2,000. Looking at others, we can all see that the prices is increasing. And that's why we need to reclaim the material that we have used underground instead of buying new ones. Implementation. I'll take you through the reclamation process. Reclamation process starts when a material is being purchased to go and be used underground. For example, a winch and a fan are shown below with their prices of a new material. We can all see that the material, to buy a new material, for example, the 37 kilowatt scraper winch, it costs approximately 80,000, which is a high amount of money. After being used underground, the material is left in the old working places. For example, the scraper winch shown and the water pipes. They are being used and left underground. Reclamation team. The team goes underground, and the team consists of the miner, the team leader, the 2 laborers, and the 2 winch drivers. They carry their equipment, for example, the snatch block and the chain block, and all other equipment that are necessary. The material is transported from the old working areas. After the material has been reclaimed, it is taken out, for example, the winch, scraper winch, and the water pipes. They are all taken out from underground to the shaft. When they are taken from underground to the shaft, for example, they can be taken from one level to another. Looking below, it's rock props. They were assessed and they found out that they are still in good conditions. So they took them from the level 29 crosscut 55 to another level. And this saves almost 100% of the costs. Another scenario is that the material that is taken underground, it is transported to surface. For example, the winch and the scrap metals that are taken from underground and to the surface. When the material is taken from underground to surface, it can be taken to salvage. The material taken to salvage, it is because the material is scrap or the material cannot be reclaimed. There are some materials underground that cannot be reclaimed. The reason being, they will pose risk to the workers if reused again, and that material is taken to salvage. Another scenario is that the material is taken for refurbishment. For example, the scraper winch shown, it is taken to Driefontein to be refurbished, and it will be taken back and it will look very brand new, and all the parts are being fixed. Another example for refurbishment is the fan shown that will be taken to Driefontein and it will come back looking brand new and in good conditions, and it can be used again underground. Lastly, the ventilation pipes. They are taken from underground, taken to Driefontein, and they come back looking brand new and they can be used again. And this process saves the mine 80 to 90% of its cost. Finally, the material that has been reclaimed, it is all gathered together so that they can calculate how much they've saved the mine. Evaluation and control. The graph below shows, in the orange bar graph, shows the amount that they need to pay if they buy a new material. For example, the 37 kilowatt winch, it's approximately 80,000 to buy a new one. But if we reuse the material, which shows in the blue graph, we spent almost 20,000. And also, if we refurbish the material that we took underground, we spent only almost 30,000. From the difference between the capital cost and the cost for reuse and refurbish, we can see a huge difference. And this shows how reclamation can save mine costs. Evaluation and control. The table below shows all the equipment that a team took underground. They took 3 metric winches, 2 fans, and a cooler car. For them to buy the 3 new metric standard, they will have to spend 336,000. But if they refurbish the material that they took underground, they will only spend 201. They will only spend 134,000, which means they've saved 201,000. We can see instead of buying a fan, 2 fans, which will cost 50,000, they can refurbish the old fans and they will save 20,000. And also, instead of buying a cooling car, which will cost 263,000, they can only spend 26,000 if they reuse it, which means they save 236,000. When we look at the cost saved by reclamation, we also need to consider the cost of labor. For example, the table that I showed previously, the cost to buy all that new material, they will cost 650,000. But if they have reclaimed the material, they will only spend 191,000, which means they've saved 458,000. But we have to consider the cost of labor. In a team, they work in a group of 7, and cost per man per day is 376. If the men worked for 28 shifts, they will pay the individual 10,000. For the 7 crew, they will only pay 73,000. From the 458,000 that they have saved from the material, they subtract the 73,000 that they paid the laborers, still they can save an amount of 385,000. This shows how much they can save the mine costs. Finally, with recommendation, I recommend that they perform monthly maintenance on the materials. This is because if a material has been monthly maintained, when the crew leaves it in the old working places and the reclamation team comes, the material will still be in good conditions, and in that way, it has increased in value. Another recommendation is that I recommend the effective communication between the planning team and the reclamation crew. This is because the crew that has left the stope, it is going to a new working place. And that means they will need the equipment as soon as possible. So if they move to the old working places early, they'll be able to save the crew time for production, and they will quickly take the new material after being reclaimed. Also, this is because they will be able to mitigate the loss of losing material due to mine closure. This is because the material, when left underground, it loses value due to deterioration. But if they go underground immediately after the crew leaves, they'll be able to take the material while it is still in good conditions. Again, this is because they have to mitigate the risk to worker safety. If they go underground while the place is old, there is a heat there and they can pose risk to mine workers. Lastly, this is crucial to prevent water damage to the material. Because the material, if it's left in the old working places, the water will damage the material and it cannot be reclaimed. Additionally, they need to optimize the transportation team responsible for moving material to the surface or other levels. This is because the material is left in the working places for so long, and that can affect the time for production. They need to hire a worker that will assess the material being reclaimed before going underground. Some materials are taken underground while they think they are fixed, but they are not. So they need a mine worker that will assess the material before it is taken underground to avoid additional cost of transportation and also delay to the new working place. Lastly, for safety, they need to sort the material well